Okay, electricity and chemistry, electrolysis. Now, the basic idea to get into your head is that if we use electricity as a form of energy, we can get chemical reactions to happen. And that's what electrolysis is. Electrolysis is using electricity to break up ionic compounds. And we break them up into their elements. Okay? So you've seen that ionic compounds form when two elements combine. For example, sodium and chlorine, they combine quite violently to form sodium chloride. And they form a very stable lattice, an ionic lattice, and they're quite innocuous. So you can put sodium chloride on your chips. But sodium and chlorine are very reactive elements. Now, to get them back, to get them to be elements again from sodium chloride, the compound, we need energy. And electrolysis provides that energy in the form of electricity, and it breaks up the ionic compound. What is electricity? An electric current. Well, this is something you've probably come across, and your first reaction will be to say, oh, it's electrons flowing in a cable. But it's a broader term. Electricity is the movement of charge. It could be electrons, but it could also be something called ions, which we've seen, which are charged particles. And it could also be protons. Protons have got a positive charge, so if we had a beam of protons, then we'd have an electric current. It couldn't be neutrons, because neutrons are neutral. They don't have a charge. Okay, so it's the movement of charge. That's the general term. In electrolysis, we have a basic setup, like that shown. You've got some kind of container. It's often glass in the laboratory, but this could be metal, especially if it's a higher temperature. And within that, you have ions. You've got positive ions and negative ions. This is the electrolyte. We'll talk about these definitions in a second. You've got cathode and an anode. We'll define them. And you've got a cell or a battery with a negative end, which is the left-hand side here, and the positive side. So this is the idea. This is the basic arrangement in order to make electrolysis happen. Let's get some more definitions. So there's that particular setup. My electrodes are the rods that carry the electric current to and from the electrolyte. Okay? So that they look like graphite here, and they often are graphite. They're rods that conduct electricity, and they carry the electrons from this cell. They carry them to and from the electrolyte. Okay? The cathode is the negative electrode, and the anode is the positive electrode. Now you can see that from this cell, this side is the positive side, isn't it? So this is the anode. This side is the negative side, so this is the cathode. The electrolyte is, in this case, the molten liquid or solution, which contains ions that can move around. So if we've got a molten ionic substance, the ions can float around and they're free to move. And just to remind ourselves, iron is a charged particle or species. It has a charge. It's not neutral. Right? So let's look at the electrolysis of molten ionic compounds, and the absolute classic is lead bromide. A lead bromide, I think it's got a melting point of about 350 degrees C. So you have to heat it with a Bunsen burner to get it to melt. Okay, similar kind of setup. You've got the electrodes here. You have your crucible, which is something that withstands quite high temperatures. Molten lead bromide inside the crucible. So you've heated it up with the Bunsen burner, and then you've got the positive electrode here, the anode, and the negative, the cathode. Okay. Ionic substances will only conduct electricity when molten, because the charged ions have to be able to move around, don't they? Takes a lot of energy to heat these things up, so that's something to take into account. Let's have a look at the ions that are present in molten lead bromide. We know that from the formula we have Pb2+, so we've got Pb2 plus ions, and then we've got, for every mole, we've got 2 Br minus ions, bromide ions. So we've got lead ions and bromide ions. And what do? Well, once we connect this circuit, then this is the negative electrode, the cathode. If it's negative, it attracts the opposite charges, so it attracts the lead ions. This is the anode, this is positive, so it attracts the opposite charges, the bromide ions. Okay. That all makes sense, doesn't it? It's what happens when they get to the electrodes that's going to be interesting. So the Pb2 plus ions move to the cathode and lead atoms are formed. So for Pb2 plus to become a lead atom again, what must happen? It must gain electrons. So you have Pb2 plus, it gains 2 electrons and it becomes Pb, lead atoms. What would you see? Well, after a while you would see a small silvery ball of molten metal underneath the cathode. Bromide ions go to the anode, obviously, and they form bromine atoms. To do that, what must they do? They must lose an electron, so they become Br. The thing is, Brs, bromine atoms, don't float around on their own. When you get a bag full of bromine atoms, the atoms pair up to form bromine molecules to try and get a little bit more stable. So we have to say that 2 bromide ions lose an electron each to form a bromine molecule, and they're the 2 electrons. Bromine, in these conditions, because it's quite warm, bromine will form a vapor. So you see a brown vapor rising around the anode. Bubbles come up through the liquid and form brown vapor. Now these 2 equations here are called half equations because each of them is half of the story of what's happening within the crucible. So we combine them, we add them together. There's 2 electrons on this side, there's 2 on this side, so they cancel, and you get that. Basically, 1 mole of lead bromide is forming lead and bromine. So there's the overall equation. Okay, you can see that on the video. Take your time and have a look. Okay, let's continue with this. Just a few more definitions. Anions, they are negatively charged ions and they go to the anode. So anions go to the anode. So in this case, the anions were the bromide ions, weren't they? Cations, well, it's the opposite, isn't it? They're positively charged and they go to the cathode. In this case, they were the lead ions, weren't they? The lead ions were the cations. Electrodes are usually made from graphite. In this particular electrolysis, graphite was the perfect thing to use. Why? Well, several reasons. One is they conduct electricity. Obviously, graphite conducts electricity. 2 is it has a high melting point. Graphite's melting point is over 2000 degrees. And also it's inert. It's unreactive. We don't want it to react with any of the things that are present, do we? Okay, we often call it a passive electrode. Doesn't take part. When ions lose or gain electrons, they form neutral atoms and then molecules, and we say that they have been discharged. They've lost their charges. Okay, we've just mentioned this. Many cases, most of the cases you'll come across, the electrodes will be inert or passive. They don't take part in the reaction. Graphite's a good example. Platinum's another good example. Okay, so the electrolysis we've just seen of lead bromide, we can apply that to different contexts. We can apply it to other molten ionic substances. Okay, so we're going to try and use that pattern to predict which elements will be formed and where for the following ionic substances. So we'll start with aluminium oxide. Aluminium oxide is going to break up to form aluminium and oxygen. Which of those two will be formed at the cathode? Well, the cathode is negative, so which is the positively charged ion here? The aluminium. So you'll get aluminium metal at the cathode, and at the anode you'll get oxygen gas. Those are the products. We try zinc bromide, then we're going to get zinc at the cathode and bromine at the anode. Potassium chloride, we'll get potassium at the cathode and chlorine at the anode. Lithium iodide, we're going to get, you can see it now, lithium at the cathode and iodine at the anode. Okay, it's nice and simple. There's only two things present and we get each of the elements back. Like I say, the electrical energy causes these ionic substances to break up, and that's what electrolysis is. Right, have a go at the questions on the pages indicated, read through the pages, make sure you understand the text.